A planet spinning at over 1,000 miles per hour, carrying polar ice caps so heavy they can only be measured in exponential notation, suddenly sheds those weights, and the crust of the Earth tears open in response. That is not a metaphor. That is geophysics. Today, we are getting into the forces that built toward the Toba supereruption around 80,000 BC, specifically what the long-term climate record actually shows, how polar ice and volcanic systems are connected in ways that will genuinely surprise you, and why this near-extinction event still echoes in our DNA. I've got someone here who has spent serious time in this material, and I want to start with the most basic question that somehow nobody asks. What actually is Toba, and why does it matter so much?
So Toba is Sumatra's largest caldera, and calling it a volcano is, honestly, deceptive to the point of being tragically wrong. Lake Toba, as we know it today, the lake that formed in the mouth of the caldera, is 85 kilometers long and 33 kilometers wide. But that is just the magma plug. The actual caldera is so large you would need to be in space to view it in full. To give you a sense of scale, the known molten region of Sumatra's largest caldera is large enough to cover nearly all of England and Wales.
Wait, all of England and Wales?
All of England and Wales. And the search results I've been working through are very clear on this. Toba is not a city killer. Toba is described as a planet killer. And even Toba is nothing compared to its source, which is a magma seam that runs all along the Himalaya mountains and defines the Pacific Ring of Fire.
So we are not talking about one rogue volcano, we are talking about a system.
Exactly, and that is one of the more provocative arguments in the material I've been looking at. The case being made is that a major eruption on this magma seam almost certainly could not have been limited to Toba alone, that it likely involved volcanic activity all along the seam, which would make it a supereruption in the truest sense. Multiple volcanoes, one connected system. Academic consensus currently confirms only the single cataclysmic event at Toba, but the underlying geology makes a broader event at least plausible.
And the human consequences of this, they are not just archaeological, they are genetic.
Right, and this is where it gets genuinely unsettling. Genetic research has shown that the human population crashed as a result of the Toba eruption. Only 3 mitochondrial DNA pools remained after the event. 3. That means every human being alive today traces back to an extraordinarily small group of survivors.
3 mitochondrial DNA pools. That is almost incomprehensible.
It is. And to put the human population at that time in context, the total number of breeding pairs on the entire planet around 80,000 BC is thought to have been no more than 26,000. Some arguments push that number higher, some lower, but 26,000 breeding pairs was the rough consensus. And then Toba happened.
So we are talking about a population smaller than a mid-sized town today, spread across the entire planet, and then a near-extinction event on top of that.
Exactly. And what makes that number even more interesting is an archaeological site discovered in Malaysia, just beneath the Toba ash layer. At this site, archaeologists found tens of thousands of stone tool fragments and thousands of stone tools across a 2-acre area. The density of finds is described as indicative of industrial-scale production, not just a few people scooping flint, but organized, widespread manufacturing and trade.
So the people living right next to Toba were not primitive wanderers. They were running what sounds like a regional economy.
That is the implication, yeah. The necessary population of tool makers and tool users at that site alone exceeds the consensus estimate for the entire human population of the planet, which either means the consensus estimate is wrong, or the sophistication of these communities has been dramatically underestimated. Probably both.
And the ash layer itself, that is the physical boundary between before and after.
It is. The Toba ash layer is described as the boundary between prehistory and history in the material I've been reading. Everything below it is one world, everything above it is another. And what is striking is that compositions and iconographic writing begin appearing in the archaeological record immediately after the eruption, as if the survivors felt an urgent need to document what had happened and what remained.
That is a haunting detail. Okay, so let's back up and build the geophysical picture, because I think to really understand why Toba happened when it did, you need to understand what was going on with the climate in the lead up. And the Vostok Dayslip is central to that.
Right. So the Vostok Dayslip is derived from sedimentary cores taken from around the world, and it is widely accepted as the standard for climatologists. It documents fluctuations in Earth's temperature across 5.5 million years of history. And the first thing to understand is that the long-term trend in that data is not warming, it is cooling.
Global cooling over millions of years.
Over millions of years, yes. Early in human history, global mean temperatures were increasing by an average of around 2 degrees Celsius per period. Later in human history, they were dropping by anywhere from 2 to 8 degrees Celsius. But, and this is critical, the data also shows that the climate has become increasingly volatile over time. Bigger swings, more dramatic spikes.
So it is not a smooth decline, it is a jagged, increasingly chaotic decline.
Exactly. And within that long-term cooling trend, you see these recurring spikes, periods of rapid warming followed by sudden dramatic cooling. These are called interstadials, which is essentially the technical term for the end of an ice age. And here is the pattern that the Vostok data makes very clear. A rapid period of warming immediately precedes every single ice age. Every one.
So warming causes ice ages, which is completely counterintuitive.
It is counterintuitive, and that is exactly why it gets missed. The mechanism is not temperature directly, it is weight. And this is where the argument gets genuinely fascinating. The search results use this analogy of a car tire. A tire has balancing weights added to it to compensate for imperfections in its shape. Those weights keep the tire stable as it spins. Remove the weights and the tire wobbles. Spin it fast enough and eventually something blows.
And in this analogy, polar ice is the balancing weight.
Polar ice is the balancing weight. Water weighs 8 pounds per gallon. When you scale that up to the volume of polar ice caps, and we are talking about mass that can only be expressed in exponential notation, you have continent-crushing, mountain-forming quantities of weight sitting at the poles. And that weight is not static. It accumulates over hundreds of thousands of years and then disappears within a few thousand years when warming kicks in.
So the planet is essentially rebalancing itself every 100,000 years or so, and that rebalancing is violent.
Profoundly violent. And here is why. Our planet is not just spinning on its axis, it is orbiting the sun at around 67,100 miles per hour, and the entire solar system is orbiting the center of the galaxy at around 449,000 miles per hour. At those velocities, any redistribution of significant mass across the planet's surface alters the center of gravity and changes the rotational momentum. That change induces torque forces at the crust-mantle interface, the boundary between the solid crust we stand on and the molten rock beneath it.
And those torque forces are what we call tectonic activity.
Tectonic activity, yes. The search results describe the Earth's crust as being like an egg whose shell is cracked all over from being handled too roughly. Along the seams of every crack, material oozes out and dries to form part of the shell. These are the tectonic plates, and the place where the planet adjusts most dramatically when mass is redistributed is the India-Pacific plate boundary, the same boundary that sits directly beneath the Himalayan magma seam and directly beneath Toba.
So the chain of events is warming melts the ice loss redistributes mass redistribution destabilizes rotation, destabilized rotation tears at the plate boundary, and the plate boundary ruptures at its weakest point, which is Toba.
That is the argument, yes. And the ocean level data supports it. The search results include a graph of global ocean levels across the last 250,000 years, and it directly mirrors the Vostok temperature data. When temperatures increase, ice melts, ocean levels rise. When temperatures drop, ice forms, ocean levels fall. In the period between roughly 138,000 BC and 123,000 BC, the Earth's climate was warming and ocean levels were rising. Then something stopped the rapid warming, and whatever it was continued to cool the planet until the supereruption of 80,000 BC.
And in 80,000 BC, sea levels were about 45 meters lower than they are today.
Around 45 meters lower, yes. Which means the geography of the region looked completely different. The majority of Indonesia was connected to the Asian mainland. Borneo and Sumatra were part of what the search results call Greater Malaysia, a continuous landmass stretching from the Asian continent down through what is now the Indonesian archipelago. Australia was connected to Papua New Guinea. The world was physically larger in terms of habitable land.
That is a completely different map. And Toba sits right in the middle of that connected landmass.
Right in the middle. And the communities living in that region, particularly along the Kapuas River in what is now Borneo, were not isolated. The search results describe a river system that, at those lower sea levels, connected central Borneo all the way to the headwaters of the Mekong in what is today China's Yunnan province. So you had navigable waterways linking communities across an enormous region, all of which would have been in the path of what was coming.
And the glacial maximum, the point at which the ice was at its absolute peak, that was around 24,500 BC, right? So by 80,000 BC, the planet had already been cooling for a long time.
The glacial maximum was around 24,500 BC, yes. So that is actually after Toba. What the data shows for the period leading up to 80,000 BC is that the planet had come off a rapid warming spike, the kind of interstadial we were just talking about, and was in the process of cooling again. Polar ice was accumulating, mass was being redistributed back toward the poles, and the India-Pacific plate boundary was under increasing stress.
So the ice was building up, the planet was rebalancing, and the pressure was accumulating along the magma seam.
And the search results make a point about the scale of force involved that I think is worth sitting with. The argument is that if all the nuclear weapons in the world today were detonated simultaneously along this magma seam, they would not budge the India-Pacific plate in either direction. The forces generated by the redistribution of polar ice mass are simply in a different category to anything we have built.
That is a staggering comparison. All nuclear weapons ever built, not enough to move the plate.
Not enough to move it. And yet the redistribution of mass caused by the end of an ice age does move it. That is the scale of force we are talking about when we say the ice ages and volcanic supereruptions are connected. It is not a metaphor. It is a direct mechanical relationship.
I want to come back to the human side of this for a moment because there is a detail in the search results about the island of Flores that I find genuinely fascinating. The Homo floresiensis discovery.
Ah, the hobbits. So, archaeologists uncovered hominin remains in a cave on Flores and attributed them to a new species called Homo floresiensis. These individuals rarely exceeded 3 feet 5 inches in height, which is why they got dubbed hobbits. The conventional interpretation is that they were a primitive, small-brained subspecies not capable of complex behavior. But the search results push back on that hard.
In what way?
The argument is that island dwarfism, a genetic response to sudden limits in available nutrition, is almost certainly responsible for their diminutive size. And the suggestion is that once DNA samples are properly acquired, they will prove to be Homo sapiens sapiens, not a separate species. Small bodies as an adaptation to resource scarcity, not evidence of primitive cognition. It is a completely different reading of the same physical evidence.
And these communities on Flores would have been in the region when Toba erupted.
They would have been right in the thick of it. The search results placed them along the Kapuas River system, part of the broader network of communities that were thriving in Greater Malaysia on the day the eruption happened, which makes the question of who survived and how they survived all the more pressing.
And the answer to that question is written in our DNA, 3 mitochondrial pools, 3 lineages that made it through.
3 lineages. And the search results make the point that we know there were survivors because of what comes after. The iconographic record, the compositions, the evidence of communities rebuilding and documenting their world. The ash layer is the dividing line, and on the other side of it, people were already writing things down.
Let's talk about the climate cycle more broadly, because I think the Vostok data has implications that go well beyond 80,000 BC. The search results describe a pattern that has repeated at least 11 times in the last 1.3 million years.
At least 11 similar spikes in the dataset, yes. Rapid warming, followed by rapid cooling, followed by an ice age. Every single time. And the argument being made is that this is the fundamental rhythm of the planet, not a linear trend in either direction, but a cycle driven by the interaction between the hydrosphere, the atmosphere, and the weight of polar ice.
The hydrosphere pumps water into the atmosphere dumps it on the continents, and whether it falls as rain or snow depends on the temperature.
Exactly. During warming periods, it falls as liquid. During cooling periods, it falls as snow and accumulates as ice. And as ice accumulates at the poles, the balancing weights are being added back to the tire. The planet stabilizes. But then the next warming spike comes, the ice melts faster than it accumulated, the weights are removed suddenly, and the whole system lurches again.
And the current warming trend, the one we are in right now, began around 12,500 BC, according to the search results.
Around 12,500 BC, yes. The search results call that the older Dryas, the beginning of the current warming trend. And polar ice has been melting since then, continuously, to this day. The search results are quite direct about this. Polar ice continues to melt to this very day.
Which means, if the pattern holds, we are somewhere in the warming phase of a cycle that has previously ended in a supereruption and an ice age.
That is the implication of the data, yes. And the search results are careful to distinguish this from climate alarmism in either direction. The argument is not that we are about to cook, and it is not that human activity has no effect. It is that the geophysical forces operating on timescales of tens of thousands of years are simply in a different category to anything driven by industrial emissions, and that understanding those forces is essential to understanding what the planet is actually doing.
There is something almost humbling about that framing. We are used to thinking of climate as something we are doing to the planet. But the Vostok data is showing us a planet that has been doing this to itself repeatedly for millions of years.
And doing it on scales that dwarf anything in recorded history. The search results make the point that everything we know from books, the Upper Paleolithic, the Neolithic, the Bronze Age, the Iron Age, the Medieval Period, the Industrial Age, all of it fits into a tiny box on the far right of the Vostok graph. All of human civilization as we know it is a footnote in the geophysical record.
That is a genuinely vertiginous thought.
It is. And it is why the Toba event matters so much as a reference point. It is the one moment in that geophysical record where we can see the full mechanism in action. The warming spike, the ice loss, the tectonic response, the eruption, the population crash, and we can trace its effects all the way into our own DNA.
Let's talk about the ocean level data for a moment, because I think it adds another layer to this. The search results describe dramatic fluctuations in global ocean levels across the last 250,000 years.
The ocean level data is striking because it is such a direct mirror of the temperature data. When temperatures rise, ice melts, oceans rise. When temperatures fall, ice forms, oceans drop. At the glacial maximum in 24,500 BC, ocean levels were 125 meters lower than they are today. 125 meters. The coastlines of every continent were in completely different places.
And at the time of Toba, 80,000 BC, they were about 45 meters lower.
About 45 meters lower, yes, which is why Greater Malaysia existed as a continuous landmass. And the search results note that there is actually only one period in the recent past, the beginning of the last ice age, when global oceans were slightly higher than they are today. So the current rise in ocean levels is real, but it is part of a pattern that has been playing out for thousands of years, not something that began with industrialization.
And the water that is currently in the oceans, it came from somewhere. It came from the ice.
It came from the ice. And the search results make the point that there is not much left. What little water remains locked in polar ice is melting. The oceans will rise a bit further, but not dramatically more, because the reservoir is nearly depleted. The big question is what happens next in the cycle. Because if past is prologue, the next chapter involves a rapid cooling trend and the beginning of a new ice age.
Which would be triggered by what? Another supereruption? Or does the cooling come first and the eruption follows?
The argument in the search results is that the eruption is a consequence of the ice dynamics, not the cause of the cooling. The cooling is driven by the geophysical cycle, the planet's own rhythm. The eruption is what happens when the redistribution of mass along the plate boundary reaches a breaking point. So the sequence is warming, ice loss, mass redistribution, tectonic stress, eruption, volcanic winter, accelerated cooling, new ice age.
Fire and ice. The title of the source material is literally Fire and Ice.
And it is an apt title. The search results describe fire and ice as the two forces that drive these climate spikes, volcanic fire and polar ice, locked in a cycle that has repeated at least 11 times in the last 1.3 million years. Our ancestors, according to the material, understood this intuitively. The concept of yin and yang, of cycles where the end of one is the beginning of the next, the search results argue that is not mysticism. It is a folk memory of geophysical reality.
That is a remarkable reframing. Ancient cosmology as climate science.
And the search results are careful not to romanticize it. The point is not that our ancestors had modern scientific understanding. It is that they were observant, reasonable people working with a much larger data set than we give them credit for, one that included direct experience of climate volatility on scales we have never witnessed in recorded history.
I want to come back to something you said earlier about the younger dryas, because that is another data point in this cycle that I think is worth flagging.
The Younger Dryas is a brief relapse in global cooling that interrupted the current warming trend around 9,300 BC. So even within the current warming period that began around 12,500 BC, there was a sudden reversal, a cold snap essentially, on a geophysical scale. And the search results note that the iconographic record, the compositions and writing systems that emerged after Toba diversified across the globe until the Younger Dryas, and then something shifted again.
So even the recovery from Toba was not smooth. There were further disruptions.
Nothing about this system is smooth. That is the point. The Vostok data shows a climate that is increasingly volatile, bigger swings, faster transitions, and the human populations living through these transitions had to adapt continuously, not just once.
Which makes the survival of any lineage through 80,000 BC all the more extraordinary.
Genuinely extraordinary. And the search results frame it in terms that I find quite moving. The argument is that the survivors of Toba were not just lucky. They were the ones who had the knowledge, the social structures, and the navigational capability to find refuge and rebuild. The iconographic record that begins immediately after the eruption is evidence of that capability.
So when you step back from all of this, the Vostok data, the ocean levels, the tectonic mechanics, the DNA evidence, what is the through line? What does it all actually add up to?
The through line is that the Toba supereruption was not a random catastrophe. It was the predictable output of a geophysical system that has been running the same cycle for millions of years. Rapid warming melts polar ice. Melting ice redistributes mass across a planet spinning at extraordinary velocity. That redistribution alters rotational momentum, induces torque at the crust-mantle interface, and eventually tears open the weakest point in the plate boundary. In 80,000 BC, that point was Toba.
And the human population, 26,000 breeding pairs, reduced to 3 mitochondrial lineages, somehow made it through.
Made it through, and then started writing things down. Which is, when you think about it, the most human response imaginable to a near-extinction event. You survive, and then you make sure no one forgets what happened.
Here is what this really comes down to, I think. We tend to look at climate and geology as separate conversations. One is about carbon and weather, the other is about rocks and deep time. But the picture the Vostok data paints is of a single integrated system where ice, ocean, atmosphere, and tectonic forces are all talking to each other constantly.
And the conversation happens on timescales that are genuinely difficult for human minds to hold. The warming spike that preceded Toba played out over thousands of years. The eruption itself was probably days or weeks. The volcanic winter that followed lasted years. The ice age that eventually came lasted tens of thousands of years. All of it connected, all of it part of the same cycle.
And we are, right now, somewhere in that cycle.
We are. The current warming trend has been running since 12,500 BC. Polar ice has been melting continuously for over 14,000 years. The ocean levels are near their historical high. If the pattern holds, and it has held at least 11 times, the next phase of the cycle is a cooling event. The search results are not predicting when or how. They are just pointing at the data and saying, this is what the pattern looks like.
And the actionable insight from all of this, if there is one, is probably that understanding the full geophysical picture matters. Not just the last 100 years of data, not just the industrial era, but the full 5.5 million year record.
That is exactly it. The search results make the point that climate alarmism in any direction, whether it is panic about warming or denial of any change, is dangerous precisely because it narrows the frame. If you only look at the last 100 years, you see a spike and you panic. If you zoom out to the full Vostok record, you see that spike in context, as one moment in a cycle that has been running for millions of years, driven by forces that dwarf anything human activity has produced.
And Toba is the most vivid example we have of what happens when that cycle reaches its peak.
The most vivid and the most personal, because it is in our DNA. Every human being alive today is descended from the people who survived that event. The 3 mitochondrial lineages that made it through are the foundation of every human population on Earth. Toba is not ancient history. In a very real sense, it is our origin story.
That is a remarkable place to land. We started with a planet losing its balancing weights at 1,000 miles per hour, and we end with the realization that the survivors of that catastrophe are the reason any of us are here at all.
And they did not just survive, they built something.
The iconographic record that begins immediately after the Toba ash layer is evidence of communities that looked at what had happened and decided to document it, to make sure the knowledge survived even if they did not. That impulse to record and transmit understanding across generations is what makes us human.
So the next time you look at a map, or read something written down, or think about where language comes from, there is a line that runs all the way back through 80,000 years to a group of people sitting on the other side of a volcanic winter deciding to write it all down.
And the ash layer is still there, physically, in the sediment, all around the world. A thin gray line that marks the moment the planet nearly reset itself. Everything above it is us. Everything below it is what we almost lost.
That is the kind of detail that stays with you. A thin grey line in the sediment, and on one side of it, almost nothing. On the other side, everything.